Here is Grade 7, Module 9, Lesson 2. Our I can statement is I can determine whether three lengths could be side lengths of a triangle, and given two side lengths, I can find the range of possible lengths for the third side. So here is our triangle inequality theorem. So it states that for any given triangle, the sum, so sum meaning our addition, the sum of the measures of any two sides must be greater than the measure of the third side. So the reason for that, if you think about it, we have two side lengths. Say we have B here, and B equals 10. That's our B. And say A coming up here is 6. And C over here is 4. Would that make sense? Would that follow our triangle inequality theorem? No, because you would have 10 on the bottom, and 6 and 4, those measurements here, will just barely high-five each other. 6 will lay right here, and, or I'm sorry, 4 will lay right there, and 6 would just barely touch, but there would be no space in between these. Okay, it would be essentially two lines on top of each other. So what they're saying is that A and B, those two sides, need to be greater than C. They cannot equal C. They must be greater than C. And that goes for all of the sides. So if you have a B and a C, those need to be bigger than A, and then A and C still need to be bigger than B. But always try and visualize that when you're going through these problems. Will they kind of lay on top of each other, or can they not even reach? Like say we have one side that is 8, one side that is 3, a little bit longer there, and then the other side is 2. Would that even touch? They couldn't even high five. They would lay reaching, but they wouldn't even touch. Okay, so that triangle wouldn't work. This C side here would be too long. It doesn't matter which one is A, which one's B, which one's C, as long as you just make sure you keep them all straight. So as you are working through each of these problems or inequalities, you know which number is which. And to pass our triangle inequality theorem, you have to have true statements for all three of these. Okay, even one false, like 3 plus 1 is greater than 6. Okay, that would be false, so that triangle would not be possible. This 1 here would make it a little too short. All right, let's put this into practice. So determine whether each set of numbers could be lengths of the sides of a triangle. So this is imagining you have your nice long 14 on the bottom here, and we need to have a side length of 8, which is pretty long, and then a side length of 6. Now, are these long enough to where they can high five each other here and have space? Pause the video, think it over. Is this going to be a triangle just looking at the numbers? And then, does this pass our triangle inequality theorem? So let's put some variables to this. So this will be A, B, and C. So 8 plus 6 is greater, not than C, than 14. And then B plus C, is that greater than A? And I'm just looking off of this up here. And then A plus C, is that greater than B? So let's look through each of these lines. Is 14 greater than 14? Not greater than or equal to. Greater? No, it is not. This line here is false. The other two are true, though. This will give me 20. This would get me definitely greater than 6. True, true. But what this would end up looking like is one line on top of another. They would high five, they would touch, but there would be no space. So this one here, this one is a no. They would not be a triangle. All right, and then 3.3, we're going to write these all out too. 3.3 3.3 plus 4.4, is that greater than 5.5? And 4.5 plus 5.5, is that greater than 3.3? And 3.3 plus 5.5, is that greater than 4.4? Take a minute, pause the video, add those up. Are all three of these true? And if they are, yes, it's a triangle. If not, it is not a triangle. Okay. We have 7.7. Okay, so this is true. This is a 9. Oh, definitely true. And 8. Oh, yes, definitely true. So, yes, this is a triangle. And notice when you're adding these up, it's helpful to look at those two smallest numbers and make sure that those add up to be bigger than your largest side, because that way we get that distance, that able to high five, but there's also space in between that long C side as well.